Good morning, everyone. I am Dr. N.J. Vignesh, working as an assistant professor in the Department of Mechanical Engineering in SRM Madurai College for Engineering and Technology. Today, let us see a video on engineering graphics under the title Involute of a Square. So, what is an involute? An involute is a curve which is traced out by an end of a thread when it is unwound from a circle or a polygon, that is, the thread being kept tight. An involute of a circle is used as a tooth profile for a large gear wheel and a gear reducer. So, for example, let us take a square. Okay, I am going to take another thread and I am going to start from point A. Let us assume that this is point A and this is point D. Okay, so I am starting from point A and I am going to end at point A. So, this is point B and this is point C and this is D. I am going to take a thread. I am going to start from A and I am going to wind this entire square by using a thread. Okay, or else let us change the color. Oh, sorry. So this is point A, this is B, this is C, and this is point D. Okay, I am going to wind this entire square by using a thread. Okay, in such a way that it is exactly tight. Okay, not like this. There will be no gap in between the actual square and your thread. Okay, let us once again draw the square. Okay, if this is your square and if I am going to draw and I am going to use a thread, what will happen is that after the thread is wind, it will be looking like this. Okay, it will not be having any gap that is in between point A, B, C and D. Now what I am going to do, if this is point A, okay, if this is point A, I am starting with point A and I am ending it with point A, and I am going to slowly remove this point. In each stage, I am going to remove this thread in such a way that it is exactly perpendicular to the side of the base. Okay, for example, if this is the side of the square and if I am removing the thread on this side alone, that is in between A and D alone, and I am going to remove the thread in such a way that it is perpendicular to this side. So what will be this dimension? It will be equal to 30 mm because it is equal to length of the square. If you assume that the length of this square is equal to 30 mm, then in the next stage I am going to remove the thread from this side also. Already I have removed the thread from this side. Now I am going to remove the thread from this side also. So therefore the thread will be equal to the dimension equal to 30 plus 30, which is equal to 60 mm. Okay, so if this is my point P1 and this is my point P2, and in the third stage I am going to also remove the thread from this area. Okay, from this area also I am going to remove. So what will be the dimension or length of the thread available here? Already I am having 30, already I am having 30 here, already I am having 30 here. Okay, therefore the total dimension will be equal to 90 mm. So if I extend it, I will be able to get 90 mm. Since I am having no space here, I am marking the dimension alone. Okay, then finally I am going to also remove the thread from this point also. Okay, so this length will be equal to 120 mm. So I will be getting 4 points, that is P1, P2, P3 and P4. Now starting from A, joining all these 4 points and ending with this 120 mm thread, we will be able to generate a curve which is nothing but a cycloidal curve. So which is nothing but involute curve. So this involute profile is used to develop some profiles in gear. Okay, so this is the base with which we are going to draw this involute. Now let us move directly to the problem. With this understanding, let us directly move to the problem. This is a very simple concept. We can finish it very faster. Now let us see a problem on involute of a square. Draw the involute of a square of side 15 mm Also draw a tangent and normal at any point on the curve. So here the detailed procedure is given as I have explained you. Let us see it later on. Now let us move directly to the problem. So this is the problem. So here the dimension of the square which is given is equal to 15 mm. Okay. So what I am going to do, I am going to draw one square for a dimension equal to 15 mm. So you can draw this either using your template. If you are having a template, there will be 4 points which is exactly having length equal to 15 mm. So if you mark 4 points, then you can remove the template and join all these 4 points using a scale and pencil. You will be getting a square. So this is the first step. So first step is to draw the square for a dimension equal to 15 mm. Then we need to remove the thread from all the points. You are assuming that there is a thread which is wound over the surface of this square. Okay, we are assuming that there is a thread which is available on the surface of this square. So what I am going to do, initially I am going to remove the thread from point B and I am going to keep it perpendicular to AB. Okay, I am going to remove the point from B. You assume that the thread is initially starting from point B, okay, and once again it is ending from point B, ending with point B. So what I am going to do, I am going to remove the thread on the side AB and keep it perpendicular to point AB. Okay, so I will be able to get point P1. Okay, so this dimension will be equal to 15 mm. So don't forget, this dimension will be equal to 15 mm and exactly it is perpendicular to AB. That is very, very important. If it is not perpendicular to AB, then this procedure will be wrong. Okay, then moving on to point D. Now I am going to remove the thread along AD also. Now I am going to remove the thread along AD also. So what will be the dimension? Already I am having 15. Here again I am having 15. Therefore the total dimension of this length or point P2 will be located at a distance of 30 mm. Okay. So this dimension will be equal to 30 mm. Right. So here we will be able to get point P2. Then the third step is we need to remove the thread on CD also. So if we remove the thread on CD and if we draw it perpendicularly, here the dimension will be equal to 45 mm because 15 plus 15 plus 15 will be getting 45 mm. And note that at all the positions the thread should be placed perpendicular to the base of the square. So here it is point P3. Then finally I am going to remove the thread along the side CB also. So here the length of this particular thread will be equal to 4 times the base of the square, which is equal to 60 mm. Okay, which is equal to 60 mm. So here also the thread line should be drawn perpendicular to BC. So finally you will be getting point P4. Now I have generated 4 points P1, P2, P3 and P4, and now taking my pencil or by using my French curve, I am going to connect all these 4 points which will give me the involute. Okay, so you can also use your French curve if you are able to use it properly. Now take your pencil, starting from point B, you join B with P1, then P1 with P2, then P2 with P3 and finally P3 to P4. So these 4 points joined will give you the involute of this particular square. Okay. So this is the procedure for drawing the involute. Then next step, final step, they have asked you to draw one tangent and normal to this particular involute curve. So for drawing the tangent and normal, you can use any gap. So here in this particular problem, they have chosen the distance in between P2 and P3. You can also use the gap in between P3 and P4. So they have not mentioned any dimension. In some cases, they might be giving you some distance. You need to draw one tangent and normal at this particular distance from the base of the generating line or something else. Okay, here they have not mentioned anything. So they have simply given the question as draw a tangent and normal. 1 minute. So in this question they have asked you to draw a tangent and normal at any point on the curve. Okay, so they have chosen the distance between P2 and P3. In between P2 and P3 you mark a point M, okay, exactly at the center, and from M you draw one line which is connecting point C. Okay, from M you draw one straight line which is connecting point C and extend it. Okay, so this line CM, it indicates the normal to this involute curve. This line CM, it indicates the normal to this involute curve. Now placing your protector at point M and taking an angle of 90 degree or 0 to 180 degree, what happens, you will be able to identify 2 points T dash. Okay, actually this is T dash, so this is T dash. Okay, so this is T dash. This T dash, it touches only at this point M to this curve. Okay, so therefore this T dash indicates the tangent to this involute curve. Okay, so this is how we need to draw the tangent and normal. Very simple. You choose any point or any gap and mark a point M. From M you draw one straight line to C and extend it. So this will be the normal, and another line perpendicular to this normal and touching exactly at M alone, we will be able to generate a tangent. Okay, T dash indicates the tangent. Okay, this is how we are able to draw the tangent and normal. Finally mark all the dimensions. Okay, so at each point they have indicated the radius. So here this curve will be equal to R15, this curve will be equal to R30y, because this thread length will be equal to 15, this thread length will be equal to 30, this thread length will be equal to 45, and this thread length will be equal to 60. Okay, that is how they have marked R45, R60, etc. Okay, and the dimension of the square they have indicated as 15 mm. So I hope you have enjoyed this video. Thank you very much.